Hey guys, welcome to day 9, Understanding Aggregation, Grouping and Windows Function in Spark. Summarizing data efficiently with group by and advanced windowing is something which helps us to actually create some of the insights. If you have been following along from the beginning, you know you know how to load the data, explore it. Just let me close this up. If you have been following along from the beginning, you know how to load the data, explore it, and perform some basic transformations. But here is the truth. In most real-world pipelines, you won't just be cleaning columns, so you will be actually summarizing the data. The business leader don't ask that, okay, give me row by row data of all the sales today. What they would ask is, what was our total revenue of the region this week? Which store has the highest sales yesterday? And what's the running total of revenue for this month? For all these type of questions would be answered when we are able to aggregate upon the data. What are the different ways of grouping? If you understand this, we'll be able to start creating the right kind of summary, which is then represented in dashboards and reports and everywhere. The data set we will keep using the same CSV, but expand it with more rows to make this aggregation meaningful. So earlier what we have done is like 8 to 10 rows I have added so that I could show the column or column operation with column and other stuff, right? But this time, since this is aggregation, I have like extended the data set, added a lot of rows there. Now let's load the data and understand what is present in the data. So here what we are actually doing is we are trying to load our new sales.csv file and we'll try to see the data. What we are using is spark.read.csv and also creating a temp view for running some SQL because I wanted to showcase some of the SQL, so I'm also creating a temp view. So what happens is if you create this type of data frame, you will only be able to use the variable df to manipulate the data. But if you also create a temporary view, this temporary view is created of the same data frame but in memory. So because of that, what happens is you should be able to very easily use direct SQL by calling this variable df, whatever name you give. So it is represented in this way: df dot create or replace temp view, and then whatever name you give, with that you can do a direct SQL query. Let us move. Aggregations with group by. Let us try to understand first what is aggregations with group by. The simplest way to summarize is to group the data by one or more column and then applying aggregation function like sum, average, count, or max. Let us apply the group by region and then do a sum of revenue. All, and let's call that column as total revenue. Let's run this. What has just happened is the data frame within data frame, all the rows were grouped by region, and then there is a sum of revenue that has happened for every region. For every region, they did a sum of revenue, and they called that column as total revenue. Let us move to next set of things. We can group by with multiple columns. So we can group by first with region and then with date. Like if we have multiple entries for a date, let's say a sales data is coming for south region, we have multiple dates for which the data is present. You can do a group by on region and then date. Let us just simply run this. What you would see is the data will be grouped by first region, date, and then a daily revenue will be shown. What are different built-in aggregation functions that are available? And we generally use like 4 or 5 of them. So let's understand that. Like some we have just seen. There is something called average, max, min, and count. Sometimes we also use something called approximate count distinct, which just perform the distinct and then take an approximate count. So this is the type of, these are only like 1 2 3 4 5 6 different function, and out of that also 1 2 3 4 5, only these five, first five we use majorly. Let's again do the same operation, but this time we will do a group by region, and instead of sum, we will do an aggregation on average using the function average. So, and then let's call that column as average revenue. Let's run this, and the average or average revenue of that particular region will be printed. On the similar lines, let's add a column called max revenue. So this time we did a data frame dot group by region, and then we put max of revenue. So whatever is the max value, that will be pulled out from that column. So this is the max entry out of the west region, east region, north and south. So this way maxes can be performed. On the similar lines, we can perform min as well. So again, we did a data frame group by region, and while performing aggregate, we performed it on min. There is a function called min, and with min, we just call the column as min revenue. As I mentioned, the fifth type is count, where what we are simply doing is group by region, and then we are aggregating and counting the revenue rows, or just counting the rows within that region, so that we get the um, count, actually count of revenue. Let's call that as, instead of min revenue, maybe I just misprinted, so let's call it as count of revenue rows, and then you just simply run it, and you would be able to see that for this west region we are having two dates, east two dates, the north two dates, and south two dates, like two entries for revenue column. What is running total per region? Running total per region is a very important concept. So what we did above is a group by. Okay, we grouped it, and it's a compulsory situation where if you apply group by, you have to apply one of these aggregate functions, whether it's min, max, count, average, sum. Out of these five, you have to have at least one for a column. Otherwise you cannot group by. So group by basically flaps in all the columns. So group by collapses rows into summaries. It will always collapse the rows, so it will not, you will not have the grain of the rows afterwards. Okay, so group by collapses rows into summaries. But of what if you want running totals, ranks, or comparisons within that group, while still keeping the individual rows? So it won't keep individual rows. That's where the Windows function come in. Think of Windows function as adding length to over your data. You define a partition which rows belong together, and an order how to sort them, and then you can apply aggregation within that lens. So for example, let's understand the data first. Okay, so I just ran my select star on df. So previously I've created a temp view out of it, so I can directly run, like I can directly do that percent sql and directly run a sql query. So you can see that my data is that I have 8 entries. Out of that, each region there are two stores and particularly two dates. Okay. Now what I just wanted to see is, uh, so for each region, let's take the specific column, so that by understanding, for understanding also it will be better. So let's take date, and then let's take revenue. Okay. Let's take date, and then let's take the revenue. Let's run this. So if we run this, we can see that in east region, I can have two different dates and two different revenues. For two different dates, I have like two different revenues. So what would be running total is, what in running total I want, like east on day one, I had like 1200. The running total for day two should be 1200 plus that date's entry. So 1100 plus 1200, I want 2300 to be the answer. Similarly for north, 2300 instead of this 1100. Similarly on north, on day one, I had 1000 rupees as a, let's say, revenue. On day two, what I want is today's revenue plus the earlier revenue to be added in today's revenue. So here again I want 2300 to be the answer. Similarly for south, on day one I earned 1500, on day two I earned 900, So in total, I had earned 2400 on day 2 in South region. So day 2 in South region, I want this to be 2400. This is very helpful numbers, which helps you to kind of put it on a graph of incremental date or something, which helps you to like see whether revenue is continuously increasing or decreasing or that kind of things. Okay, so this is what I just wanted to do. Now, if I do a group by, then group by would do group by would collapse this. So if you do a group by region, it would collapse this, and then I won't be able to take sum of it. Rather, I would be able to take sum of it, but I would have only single row. So for that, I'll be using something called Windows function. What I'll do in Windows function is I'll do a window dot partition by. I would partition by region. I would partition by region, and then within that region, it will automatically keep the entries of dates, but then I would also order by date, which will help me to order it in a ascending order. So if you don't pass anything for order by, it would have it would order itself in an ascending order. So what you would get is uh, something like this. So in east you would have 102, and then revenue will be put in an ascending order by date. So smallest date would come first, and then the next one. If we apply this window function, what you would get is a running total. So I just put like uh, do this spec, do this spec, and create a new column called running total. In that, do a sum of revenue over this type of a division. So this type of table will be created, and then the running total will be counted. So what would happen is so it will start summing up the revenue for that particular data set. So only for east a section will be created, and for that sum of revenue will be done. So earlier it was 1200, so we can see that on day 1 it was 1200, but then on the next date it will sum all the previous rows, which is like 1200 plus 700, which is 2300, which I just mentioned, right? So on day 1 of north I earned 1000, but on day 2 I earned 1300. So it will be added to the previous total, and I'll get 2300. So like that we'll get a running total. Notice how Spark didn't collapse rows. It preserved each day's data, but also added new columns showing the cumulative total per region. Let us also try to rank how to apply the ranking operation. Ranking helps you a lot because it helps you to put a lot of algorithmic things. We'll create separate videos for that, but let's try and understand this first. So I have put a Windows rank, and I'm doing a partition by region and then order by revenue. If I do an order by revenue, what I would get is the top revenue order by revenue is an ascending order. So no, but I think I have put descending order. So order by revenue would happen on a descending order. So revenue 1200 is the highest, so it will come first, and then 1100 in East region store C is 1100, so it will come second. So like that the data will be distributed. So first of all it will create a small subsection by region. You can see the small subsection by the region, and within that subsection it will order in a descending order for revenue. It will order in a descending order for revenue. That if you apply rank over it, what it would give is it will start applying ranks. You can see that the highest is having rank 1. So then what you can simply do is you can filter all the stores which has rank 1, and what you would get is what you would get in the end is the store which is having the highest rank. Okay, window is not defined, so let us define window here, because I forget to run the cell. Sometimes I forget to run the cell, so let's run it again. So what we are getting here is uh, partition by created subsection. I'm just repeating it. Partition by will create a subsection. Within that subsection, you are asking it to order by revenue. You are asking it to order by revenue. So it will, and in a descending order, so it will have an highest revenue on top, and then the next set of value. and then if you apply the rank on top of it, you would get the ranks. Okay. Now what I'll do is I'll simply collect this data in a df underscore rank, df, let us simply do df underscore rank is equal to this, and then what I'll do is df rank dot filter column df rank dot rank is equal to 1 dot show. I just slightly modified the code and added and just adding the filtering for where rank has been 1. So what I will get is, let me show you the code before actually. So df rank dot show, and let me just simply comment this out. Let me simply comment this. Let's run this. So what we received is this type of data set where we know that we are ranking the store by revenue, but sometimes the question might be like, can you get me the top most revenue store, correct? So for that we just need to filter where the rank has been set to 1. So we added an additional filter here, and if we run this, we should be able to filter out those stores within a region. Like in east region, store C is having the highest revenue. Within north region, store A is having the highest revenue. Within south region, store B is having the highest revenue, and within west region, this particular store is having the highest revenue. So this is how it works. In a real life analogy, imagine you are a teacher grading student across different classes. A group by would answer what the average score per class. You collapse students into one summary per class. But a window function would answer what each student ranked within that class. You keep every student's row but add extra context. Both aggregation and both are aggregation, but windowing lets you see an individual state within. So it gives you an additional information in the context of their group. Today we learned two of the most important powerful tools in Spark: aggregation with group by. We collapse the rows to compute total, average counts, and more, and Windows function which enrich rows with running totals, ranks, and comparisons within that partition. As a data engineer, you will use this constantly, whether it's rolling up a KPI for dashboard or ranking transactions for fraud detection. Aggregations and your aggregations are your bread and butter. That's the day 9, and thank you guys for watching. This was one of the most important topic I always wanted to cover. Um, Let me check what is there for you as the next set of topic. What you are going to get is Spark joins. So we'll just understand table joins and then we'll understand how to perform them. Thank you.